I hope you all had a wonderful lunch. My name is Alicia Hoflick-Moore. I am the room chair this afternoon. I want to thank you all for joining us. Our next speaker is Katya Kovalenko, and joining us right here from the University of Minnesota. They'll reserve some time at the end for questions and answers, so feel free to submit those online or hold those to the end, and we'll have a few mic runners to get a mic to you to amplify your voice and so they can hear you online. So please join me in welcoming Katya.
Thanks, everyone. So I am trained as a classical community ecosystem ecologist, but I do a lot of data science, primarily on natural resources focused data sets. And the why for this talk is if you search for data science workflows, you will end up with something like this beautiful flow chart from Comprise, right? And it has data sources, data are automatically ingested, cleaned for outliers, analyzed, and so on. And beautiful end products are produced. However, in my experience, workflows like this, pipelines like this, are like an ideal gas. So they're wonderful if they existed, but unfortunately, in most cases, they do not exist. So first of all, the data part is the biggest part of the workflow, and everything else is kind of downstream from that. But even with that, you know, AI is going to generate amazing insights from our data. What data? And not to imply that data are garbage, most often they're kind of just different types of data that are not there yet to be automatically integrated across different subdisciplines, different workflows. And you might have seen this little fact number or whatever, that 50% of the money in data analytics is wasted, or that 70 to 80%, 90% of data analytics workflows at data wrangling. I tried to trace where that came from. I actually couldn't. So, you know, if you do a lot of this type of work, maybe try to estimate your own numbers. I'd be really interested in seeing what you come up with. So where do data like this come from? From actually analytical equipment outputs, surprisingly, because it would be a very easy fix on manufacturer's side. Lack of training, legacy data. This one is my anti-favorite, is data designed to look good in print. So even though we no longer, you know, print our little tables and post them somewhere, for some reason people still keep doing this, really unnecessary, and results in a lot of work downstream. Sometimes embedded summaries, which is not a good data practice to have embedded summaries with your data, but actually fairly easy to clean. And then multi-purpose complex lab data sheets. So from here on, if you don't see something on the slide, that means you're not supposed to. So don't worry about trying to read it. The point I'm trying to make here is there are a lot of going on in this field, in this case, stream survey. And if this data are transcribed as is into a single, say, Excel, it would be a very messy, and definitely not machine-readable. And then data from external collaborators. And I have colleagues in academia and industry, and when I ask that question, they say, we just don't ingest those data, we don't use those data. We go back and we tell people, you need to submit a new data set that we can work with. This is not ideal for a couple of reasons. One is that you know, you may never get any data. And if it's critical data for your, say, meta-analysis, you probably don't want that to happen. But secondly, because if people generated data in that format in the first place, you probably don't want them to be the ones cleaning it, because they may resort to manual cleanup, and it's very error-prone, so it's always better to have an annotated workflow on your side. And even in data-intensive fields, such as molecular analysis, image processing. So this example, all I'm trying to show here, it's an integration of workflows of underwater imagery eDNA, and those are usually by definition machine readable because of just the quantities of data that are generated. And however, there's still humans involved, there's still ID mismatches that have to be fixed. And if you deal with a lot of ID mismatches, regular expressions in most languages are your best friend. But then also if you look at the upper part, there are water quality and sediment data, and those are very often not in the same machine-readable format. So point being that you will still have to integrate data across subdisciplines, across parts of the project. And so this is kind of, my little star up there is my UMN collaborator network, and those are just institutes. So I have 150 institutions that I've collaborated with. And this is one of the biggest things that I got out of it, that it is a lot of work and it happens over and over. And so what I hope to show in this talk is, I hope you're not intimidated by cleaning data using code. I hope you learn to recognize common data issues and the importance of annotation traceability. Kind of visualize a language-independent way of thinking about restructuring data, kind of a philosophical way, if you wish, and understand potential error sources based on structural issues as well as briefly just touch on using AI for data cleaning. And then finally, anticipate and budget for this type of work, because those of us who are senior PIs or on the grant development side of things, very often you budget for analytical, thinking it's just going to be data analysis. And it's 10 times out of 10, it overshoots the budget because of those issues. So as an example, again, a table from a paper. Don't have to see it up close, just that's how it looks like. We'll zoom in a little bit. And I want you to take a few seconds and just see what's potentially wrong with this data set from the machine perspective, right? And the first thing you notice is the column names are not really there, right? So they're multi-line, merged cells potentially, and so on. So we'll create correct column names, and I have a couple of R functions, but I'm sure you can do the same in Python. And there are IDs actually, but transposing is not a big deal at a later point. So we concatenate those IDs and assign them as correct column names. We also see some blanks. It's a PDF, so I can't tell if it's missing rows or merged cells, but there's actually a function to fill the missing row names or fill in missing cells, because people do it so often, just either to save effort typing or presumably so it looks cleaner, I don't really know, but there's actually a function to do that, which I was surprised at some point. So we'll have to convert to numeric. They're basically medians or means and ranges, and so we want only to keep the numeric data. In this particular case, if it is multiple rows, you can just do as double, it will convert everything else to an A. If there are indeed merged cells, so it's a single cell that has those values, you'll have to use regular expressions to reject it out. But before you do this, there are some less than signs in this data, and in a wide variety of fields, from pharmaceutical to toxicology to concentrations of nutrients and streams, values that are less than detection limit should never be NAs, right? Because they're not missing values, they're different ways of handling those data depending on actually substance in question and field, but they can be zeros, they can be half detection limit or detection limit. They should never be NAs, and you can't imagine how often this actually happens even in published literature when raw data gets pulled out and you see that. So also understand potential for errors here, and you can see this is definitely do not shuffle type of data set. So if you happen to sort it and saved it, you pretty much lost the data in this case. And that should never be the case. So a data set should be structured in such a way that it doesn't matter how you sort it, you do not lose information, right? And maybe for most of you it's very obvious, but again, from my experience, not always the case. A real data set, so this is a data set that there are many, many of those, and they're looking at how fast the soil is accreting and whether or not it matches sea level rise. And spoilers, it's not keeping up, but that's not the point here. So this has extensive summary stats within that. And how do I know this? Because just like IRS would go through your paperwork if you get audited, I'm actually going and tracing the formula here. And there's some raw data in there as well, so we'll look at the workflow for parsing this out. So we reformat minor IDs, and it's a little tricky here because they're very inconsistent. And then the major ID is actually part of the path. So nowhere in that file there is a major ID, so you have to splice the path and get the major ID out, otherwise the data are unusable. And then melt row names into long format. And why? The row names here are dates. And so if you try to join thousands of files and the dates are not the same, it will be very painful. And so here, as an example, I want you to think about data being, not data being pliable, but data structures. For a lot of things you do in data science, seeing how data can be reformatted basically from wide to long format will help you tremendously with generating visualization workflows and things like that. And so we'll melt it here, and then we test every significant step, and only after that we encapsulate it in a function. And when you test, I encourage you to use the smallest possible data set. Make a fake little data set, 3x4, populate it with numbers that your human mind can actually process, and only after that you can see what's happening there. Don't apply it to big data straight away, as the previous speaker also highlighted. And then no manual handling ever. And then you get it in the function, apply it to hundreds of data sets. The data are not quantitative in this yet, right? So you have to convert the dates to true dates and data to numeric because of the way it got ingested. And always test an A handling, because many functions have default ways of handling NAs, which may or may not be what you expect. So that's an important one as well. And then all in all, it's just like 15 lines of code, and it gets applied to hundreds of data sets, and it's really easy from there. And then you generate, in this case, a 1.2 million observation data set, which that number alone tells you it's not handleable. You shouldn't be handling it. You can't handle it in Excel. And only now we finally have data that can be in that beautiful analytical pipeline that I was showing earlier. Just to show how much it takes. So it took a lot of effort to get all those data, years of, decades of collecting data in the field. In this particular case, for every figure that's in those papers, just for fun, because I'm a data scientist, I like to count things, about 200 figures, unique custom figures got generated for every single one, and hundreds of analyses. Even with that, it was 10% on my side of things, 10% of effort compared with data integration workflows. A few other examples, there's a Great Lakes sediment surveillance project, which is looking at spatial and temporal distribution of toxic metals and organic compounds in the sediments of the Great Lakes. And it's a multi-pronged project and many types of analytical outputs. And at some point, all these have to get integrated into a single data set that can be analyzed across. Oftentimes, the integration workflows are field specific. You know, the Internet of Things that many people use. or very high resolution cell phone use data. In this particular case, this is water quality data that gets sampled every few seconds to minutes. Oftentimes you have to connect those data to something that is less frequently temporally sampled, such as weather data, for example. And in this case, you use fuzzy joining. Basically, you're rounding up one of the date stamps, time stamps, to match with everything else. So can we use AI for, I love doing it by hand. I feel like it's like puzzles that nobody else gets to do, right? And they're so one of a kind, every issue like this. But can you use, and this is one slide that is generated by AI, and so I have that in a disclaimer. So I asked about tools, specific tools for cleaning, and you're welcome to read it if you'd like. But what I want to say is you want to understand the prompts and the models and do unit testing the same way you do it in your code. So I wouldn't feed the entire data set and just see what happens. That becomes very quickly very untraceable. Some people use it for more basic tasks, such as column name extraction, that people always seem to have problem with that. Approximate text matching. Approximate text matching is very dangerous, though. So if you're an Excel user and you use VLOOKUP, some people are surprised to learn that it has an approximate matching function. So if you're looking something up and it doesn't find it, it'll still find something else. Imagine applying that to giant data sets, how wrong that could go. And again, can't highlight this enough, but many are one of a kind and could take just as long to test. And if you're wondering why test is, I don't know if it's real or not, I haven't tried it myself, but that's your salmon in the river here. So let's apply it to a couple examples I had earlier. And this is a sediment particle analyzer data extraction in this case. And what we have here is it's basically there's a sample ID, a whole bunch of summary stats and a figure, and then the data are actually a snake that needs to get unwrapped, so to speak. And unusual. And actually did a pretty good job. And again, ChatGPT is probably not even the best LLM for this, and I just haven't tested anything else. I did a fairly good job with a lot of rules specified, though. So I did say I need this, and that. Notice, if you can see it, that it actually made names machine-readable. So it didn't just grab the names that it had, which syntactically are not correct, with percentages and parentheses. It cleaned that up, which I found, I didn't specify that, so I found that was pretty impressive. This, I was surprised, because previous versions, I don't think they could do that. This is just an image, and I had no rules specified, and that's that metal concentration data set. And no rules specified. And it did use Python, and it did a pretty good job in that printout on the bottom. It did alert me to the less than issue, but it did not handle it correctly by default. But at least it didn't ignore it, which I thought was awesome. Now, this really fun cartoon that I liked so much is no longer funny now, because now you can send data as, not that I recommend it, but now you can send data as a screenshot of your Excel. And again, I don't think it's a very good practice here. So, yes. Now this more complex data set, and kind of make a point, it was not very successful. It was not able to get that. And in general, just based on a few examples I have tried, but I'm not a huge fan of it, because again, for me it's more expensive to test this step by step than to do it myself. So, but with a few examples I have tried, if it's an equipment machine-generated output, even though it looks kind of messy, it usually does a better job. If it's a human, this is definitely something human generated with a lot of colors and balls and that hopefully, you pray, is not carrying information because it gets lost, it doesn't do as good of a job. So that brings up kind of bigger issue, and this came out in Nature maybe a couple of weeks ago, and I really encourage you to read it, especially if you're an educator or a student. It's a conversation based partly on unpublished data, very small sample sizes, just trying to see how education will pivot with this whole new developments recently. But if you are using AI for data wrangling in this case, how do you use it as a collaborator? And I suggest you could use it in critique mode. And how would you do that? You write your own code, you upload it chunk by chunk, and you ask for critique or discussion or suggestions. But I would avoid solutions for the entire workflow, especially if you're not going to go through the steps and trace them and test them. And again, ask for specific steps, test each step on a minimal example that a human eye can comprehend. Then you have to document. Many publishers have very strict and fast-evolving guidelines for AI. And I'm an editor for Springer Nature, so I wanted to spend a little bit, it's a bit of a digression, but spend a little bit of time on this, and please feel free to ask me questions afterwards if this is the part you find interesting. But again, they're very fast evolving. There are teams of lawyers and scientists and I don't know who else working on writing those rules. Currently, AI authorship is not accepted because there's no, what does it say, accountability as in humans, so it's not accepted. You can use, if you use AI for data wrangling or like say text editing, you can say that, and usually with the text editing it's going to be okay. And publishers actually use it for both authenticate, which checks whether you're plagiarizing anything, so authenticate is, and as well as some of the tools to do initial language cleanup. So you absolutely cannot use it for peer review because it violates the ethical agreement that you have with the publisher. Notice that does not discriminate between open, AI tools and the ones that are like Gemini that we have. So it just says, please don't use it. And not only that, but when we tested it, it didn't actually do as good of a job yet. And then it is not allowing use in generative AI imagery as well. So this is why I'm saying fully document and be prepared to have it in your materials and methods if needed. And so as a bigger picture, I feel generating machine-readable data and making data machine-readable is a huge part of FAIR. And there are many aspects to research waste, which is a huge problem. But not having data available for sharing, accessible data for taxpayer-funded research in particular is a huge issue. And FAIR having findable, accessible, interoperable, and reusable data are critical to FAIR. So it is a big issue, I think. So in summary, design workflows for data integration without manual handling, even if it takes 5 times as long, 10 times as long, because you gain skills as you go along and because it improves traceability. Remember that data structures are flexible. Think about data structures as pliable and how you can rearrange to optimize joining data, making figures and things like that. If using AI, try critique or discussion mode because you will learn better and will avoid very costly mistakes down the road. And then anticipate and budget for this type of work. It's a tempting thing to delegate, and I know a lot of PIs have, say, summer students doing this, but there is no reason not to upskill those summer students. So if you are summer students, then Instead of doing this repeated manual handling, learn the code, and it's going to look a lot better on your CV, and will be less error-prone, hopefully. And with that, thank you for your time, and I'm taking any questions.
Okay, this is a question from online. How do you feel about inline AI tool for code generation, like Copilot integration in RStudio or Positron?
Probably the same way I feel about using it for data wrangling. I'd say try to use it in such a way that you learn from it, as opposed to getting ready solutions, especially if you don't understand the solution. A couple of times when I tested it, it didn't necessarily give a wrong solution, but it gave a solution in such a different direction that only after a while I realized that I don't really need to be going in this direction. There's a much simpler solution, and I'd say, again, break the problem into smaller chunks if you can. Write your code and use it in critique mode, or at the very least say, this is the little issue that I have, how would you solve it? Or even possibly, how will you solve it in multiple different ways? And hopefully it'll walk you through it. I feel like that's probably, the best.
Are there any questions in the room? Feel free to raise your hand and we can get a mic to you.
So, but to go back to this, a lot of it was trained on like Stack Overflow, and Stack Overflow is very much against AI. And so again, it has been trained on people who are uncompensated and unacknowledged, so it has that little ethical issue. But in general, if you can ask the question correctly, Stack Overflow is probably a better choice. But then if you can't ask the question well, you really are in this dangerous territory, because if you're not asking the question well, you probably don't know the answer is what you're looking for, right? So, thanks, good question.
So my question is, like, with using AI, what are the ways that we can prevent sharing like private information to AI? Because everything can happen, and we don't want to share like personal information and stuff, but we still want to get the benefit from using AI.
I mean, write your own LLM, maybe that's a possibility. Don't use AI. I mean, it depends on the level of privacy of information. For example, it has been known to spit out the entire chunks of text that it learned on, right? As supposedly independently generated, which was a big lawsuit with, I think, New York Times that they had. Just reuse that text. I'd say de-identify the information, or use your own secure LLMs, probably. But as I said, like as an editor, I would say never. Just don't use it, because it's unethical and just a bad idea. So.
Yeah, as people are thinking, I have a question. Do you have thoughts on how we might be thinking about training the future data wranglers in this time of AI? So are there skills, prompt writing might be one, but like more manual data checking skills that actually we should be emphasizing with AI, or are there other kinds of skills that the wranglers of tomorrow will need to know?
I think that's an excellent question. First of all, we need to train the data wranglers, because what we do in a lot of classes is we use ideal data sets, either data sets supplied with the packages, Kaggle data sets, you name it. But then people go into real world and they stumble, and this is one of the reasons in my experience that people are not gaining coding skills, is because they stumble, and there's so many solutions to every data wrangling problem that you get very quickly, you kind of run out of depth. I would encourage, if you train in someone from scratch, don't even go into AI yet, right? So there's a set of skills that you have to learn to understand how it works, to be able to evaluate what AI is doing. And only at the later stages, if you need it, then you could introduce in critique, suggest mode, whatever. Yeah, thanks.
Other questions in the room or online? All right, I have a lot of questions, so I'll just keep asking my own selfishly.
Sure.
Do you see AI moving into the data collection space? So we've heard a lot from you and other speakers about multiple agencies that collect data in very different ways and the struggle of data harmonization. Do you see potential for AI to actually move farther upstream in the process to help standardize data collection in the first place?
I have not thought about it. That's a good idea. I feel working with analytical, in my space, working with people with analytical labs that produce data, and explaining how important it is to have machine-readable data is probably the level of interaction that I would have, as opposed to where would you insert the AI and who would train it. So if you have people who are not generating machine-readable data, they're probably the same people who cannot test AI in step-by-step process as we suggest as best practice, right? So, but I mean, a lot of data are being generated, right, with the use of AI, such as, animal identification, videos, and stuff like that. So it is being used. It's just a question of, can it help integrate the data that are not,
How messy AI data is.
Yeah.
Yes, looks like there's a question in the room over here. Get you a mic.
Well, your question actually made me think of another one. Have you used AI at all for anomaly detection? So when I have worked with data in the past, part of the important thing in getting your hands dirty is understanding why it suddenly emerges in your research that consumption of goldfish crackers is the single most important contributor to metabolic health or something like that. You look back at the data set and you realize, only 3 people answered that question, and it's an anomalous response, and so then you can go back and correct what you're doing to deal with that anomalous data. And I'm sure with physical research, your sensors and chemical measurements and all of these things also give you plenty of instrument calibration errors, anomalous results due to one-off events. Any reflections on that?
Yes, absolutely. A lot of opinions about this. Like Esri came out with GeoAI that pretty much takes data, ingests it, cleans it, and analyzes it, and spits out the result. I'd say definitely not. First of all, use it as a backup. Did it find any of the issues that you did not find? But you are still human, is still the one, especially for outlier detection. Outliers are data points. They're not there to just throw them out. So if you have a data set of 1 million observations and you want to throw a couple of those out, you don't just throw them out. You have to say that. You have to say, okay, I deleted this and this outlier, and this is the effect it had on the relationship. And you definitely don't want someone to be doing it behind the scenes. So that's my perspective. But then if you've done it, and you okay, these are the outliers, these are the reasons I think I should delete them, and then see what the models say and if they pick anything. But in any case, like with any statistical analysis, although you're not asking about statistical analysis, but I guess a little upstream from that, like with any statistical analysis, if you apply one approach and you get one result, and then you apply a different approach and you get a totally different result, that's a problem already, right? And so one of my concerns is how easy it's going to be these days to just cycle through thousands of analyses and cherry pick the results that you want to publish. So that's another common thing, I believe. So thanks.
I think we have some virtual questions. Thank you.
So online question is, I am fully on board with not using AI for data processing and analysis, but it seems at some point it can be a huge time save. For example, making hundreds of figures. What are your thoughts on its utility at a later stage of the process?
Again, you're asking someone who's not a huge fan of that, and I have not tested its capacity to produce figures, but again, I'd say use it in suggest mode. The suggestion that I really like for figures is take a journal that is like some of the best journals in your field and just browse and look at the figures and in your head criticize those figures. And that's how you get better at building scientific figures. So if this could do that for you, it is definitely energy expensive because anything that has a visual will be energy expensive. And it generates a figure, try to recreate it, see if you can build that from scratch yourself. And then, test your code against the code that it suggests. That would be my take. But
Okay, let's take one more virtually.
What recommendation do you have for people who want to learn more about how to wrangle data, favorite resources?
which language? Because I work in R primarily. That's my main in my field. Tidyverse has great documentation, great examples. Tidyverse as a universe of packages, but dplyr and things like that. And I'm sure there are Python alternatives. Yeah, so the pandas is, yeah.
All right, let's thank Katya again.